Hello, my name is Rob Reynolds. Welcome to Mat-073. Today we're going to be looking at section 7.5 and graphing quadratic functions in vertex form. So here are some definitions that we're going to be using. Or h, if it says plus h, we're going to move to the left. If it says minus h, we're going to move to the right. If it says plus k, we're going to move up. And if it says minus k, we're going to move down. And this A term is like a vertical stretch, so it's like a rubber band, and it's going to make the quadratic either fatter or thinner. We're also going to talk about the line of symmetry and how to use that line of symmetry to create this nice U shape. So the first thing I want to show you is this applet where we can kind of play around with the values of A, H, and K. So the first thing I want to look at is just a normal graph of y equals x squared, and it's t-chart. And the t-chart for this would say if I let x be 0, then y would be 0. If I let x be 1, 1 squared is 1, and 2 squared is 4, 3 squared is 9, and then I could do this similar on the left side. Negative 1 squared is still 1. So I'm going to look at this value of a, and it's going to tell me, I start here at 0, 0, and I always go over 1 up a, and I'm going to do symmetry on both sides. So if you wanted to find some more points, you could plug into the t-chart, but I think it's important to note the movement here, over 1 up 1, and then from the vertex, it's going to go over 2 units up 4, and there's your next point. So the graph that I'm going to be showing you, it looks like it goes over 1 up 1, but it's actually 5 units. So you can see that the value of a here I've set as 5. So looking at the applet that I'm going to go to, you can see that the value of a is 5. If I decrease that value of a, notice that the graph gets flatter and flatter. And then if I go negative, it actually points down. The h value is going to move it to the right and the left. And I want to point out to you that notice in the parentheses, if it says x minus 5, it actually moved 5 units to the right. 1, 2, 3, 4, 5, and as I move closer to 0, it goes to 0, but then notice in the parentheses, it always goes the opposite direction. So if it says x plus 2, it's actually 2 units to the left. And then the d value moves, or excuse me, the k value moves exactly the direction that you think that it would move in. If it's plus k, it moves up, and if it's minus k, it moves down. You can also download this applet or view this applet at this website that's provided up here, or just Google search it. So this one, I just want to quickly show you. This goes 3 units to the right, 1 unit up is where the vertex is at, so 3, 1. This vertex is at negative 2, negative 3, so remember it's going the opposite direction here. This vertex is 4 units to the left, 1 unit up. It's also got an amplitude change, because the value of a is the amplitude of the function. And instead of going over 1 up 1, it's going to go over 1 down 3. This is going to go 1 unit to the right, 3 down. That's the vertex. The line of symmetry is always going through the vertex. So x equals 1 here, x equals negative 4, x equals negative 2, and x equals 3. And again, that line of symmetry just says the left side, so it would be this vertical line here. So if it was x equals 3, that means the left side of the parabola looks just like the right side. So you could fold it over that line of symmetry. Here are some other graphs. These are problems straight from your book, but again, whenever you see parentheses, go the opposite direction. So this one says 4 units to the right, 2 units up. And then instead of going over 1 up 1, this says go over 1 up 3. So to graph this, I'd start at 1, 2, 3, 4, up 2, and then from that point go over 1 up 3. And then use symmetry over 1 up 3, and this is what that graph would look like. The book teaches this just a little bit differently, but I'm going to continue using this graphing procedure to show you how to graph. So again, the normal t-chart says go over 1 up 1 over 2 up 4, and then we use symmetry to do the same thing on the other side. All I have to do is multiply the y value by a, and in this case a is 2. So nothing happens at 0, 0. The function stays at 0, 0. But then, since the value of a, because there's no horizontal shift or no vertical shift, so this really could be written as 2x minus 0 quantity squared plus 0. So if you put it into this a x minus h quantity squared plus k form, you can see clearly that it's not moving left or right, not moving up and down, but instead of going over 1 up 1, I'm going to go over 1 up 2, and then there's going to be symmetry on both sides. So if you wanted to find some more points, so that's this, over 1 up 2. But if you wanted to find another one, this one says go over 2 up 8. So again, those are not points that you're plotting, these are just movement charts. So from the vertex, we go over 2, 1, 2, 3, 4, 5, 6, 7, 8. So if you wanted to find some more points, all we have to do is extend our t-chart. So here's how the book chose it, but notice that they also got the point 2, 8. This one I see that this is not going to face up. This is going to be a parabola facing down. So my t-chart would look like this. Start at the vertex, go over 1, down 3, because when I multiply by this a term, then I'm really going, instead of over 1 up 1, I'll go over 1 down 3. So the vertex once again is 0, 0, over 1 down 3, over 1 down 3 on both sides, and I can see this is going to be the graph of this. If you want to find additional points, all we have to do is extend the t-chart. 2, 4 is the normal movement, but if I multiply through by negative 3, I'm going to go over 2 down 12, which is actually off my graph. So again, this is how the book is explaining all those values of positives are going to move up. 4 is going to go up 4 times as fast as just a 1. You can pause the video and read the book's directions, but I'm going to continue teaching it the way that I showed you here. This green function is the standard form, ax squared plus bx plus c, and this form, which is ax minus h quantity squared plus k, is called vertex form because the vertex is going to be this h comma k. So we'll talk more about standard form, but this video, for this purpose, we're going to be looking at vertex form. So again, identifying the value of a is 1, h is 2, and k here is 0. So this means go 2 units to the right and no units up or down. And so that's the start value. So I'll put a dot there, over 2, no units up and down, and then I just look at the value of a and do my t-chart. The t-chart says start at the vertex, go over 1 up 1, over 2 up 4. And that's what I'll do, over 1 up 1, over 2 up 1, 2, 3, 4. And then I'll use symmetry to find the other points and carefully graph this nice U shape. So you can see here's that 0.24. I would not do what the author is suggesting to do, which is just to plug in for x and solve for y. The reason why is because your calculator will calculate that for you if you just type it under your y equals. I'll look at the graph by hitting zoom 6, but maybe what's really helpful, instead of hitting zoom 6, hit second graph, because there's an instant t-chart and you can just plot those points. So I'm not a big fan of plugging in for x and solving for y, especially when you can use your calculators. So even though you can use your calculators, I would prefer that you know what the value of a does for the graph, what the value of h does for the graph, and what the value of k does for the graph. And again, the vertex is defined as h and k. And remember, if it says minus h, it actually moves to the right, so it goes the opposite direction. And if it says plus h, it moves to the left. The k value actually does what you think it should do. Positive k's goes up, and a minus k moves down. So for this example, I would start at the vertex. And in this case, if I tag on a little plus 0 at the end, we can see that the vertex is 2, 0. So I'll start there. And then I just go over 1 up 3. This has used symmetry, and 3 points determine the parabola. If you'd like to find more points, instead of going over 1 up 3, I would do a t-chart here. Over 1 up 1 over 2 up 4 is the normal t-chart. But then when you multiply by the a value, this gets multiplied by 3. And this gets multiplied by 3. And that's why you can see that the author here went over 2 and then up 12. Over 2. And here's the 2 units and up to 12 from the vertex. So again, you can pause the video here and see how the author is explaining it, but I'm just going to continue doing the same process that I've been using here. So for this one, I'm going to move 2 units to the right and 3 units down. Remember, whenever you see these parentheses, go the opposite direction. So 2 right and 3 down is the vertex. And since the value of a is 1, I'm going to go over 1 up 1, have symmetry, and then over 2 up 4. Over 2 up 4. And that's how the author does it as well. This one, it's a little bit trickier because the value of a is a negative 1/2. I'll show you how to treat that with the t-chart that I've been using. The t-chart is always the same whenever I do an x squared. I start at the vertex, not always 0, 0, but that's a movement chart. Then over 1 up 1, over 2 up 4, then you just multiply the y value by a. And in this case, a is negative 1/2. So instead of going over 1 up 1, I'm going to go over 1 down 1/2, which is hard to plot. So I would almost encourage you to go over 2 and then down 2. If you wanted to find additional points, you could. But the start value is going to be here, 3 units to the left, 1 unit down. Here's the start value. But again, instead of going over 2 and up 4, I'm going to go over 2, down 2. And if you wanted to find additional points, all we'd have to do is extend the graph. I probably wouldn't use 3 and 9 because half of 9 is not a nice point. But maybe the 4 and the 16. So again, I'm just plugging it into y equals x squared. 4 squared is 16. And then when I take half of that, another point should be negative. So over 4, down 1, 2, 3, 4, down 1, 2, 3, 4, 5, 6, 7, 8. Puts me down here. But again, even the author didn't go that far. You can see the author's trying to plot these points. Well, I would avoid them. It's hard to get accurate there. This one I'm going to go 5 units to the right, 3 units up. And then from this point I go over 1 down 2, over 1 down 2, and that makes a pretty good graph. Over 1. It was like the author even missed a little bit here, but I would have had a point here and here. This one is going to go 3 units to the right, so the vertex is 3, 1. And then over 1 up 1 on both sides, over 2 up 1, 2, 3, 4. And has nice symmetry. This one's going to go 4 units to the right, 2 units down. And again, to handle this 1/2, I would probably use my t-chart. Instead of going over 1 up 1 over 2 up 4, I'm going to multiply by 1/2. And 1/2 of 4 is 2, so that's a movement chart. Over 2, up 2, over 2, up 2. So fractions make it fatter. Numbers make it narrow. This one is going to go 2 units to the right, 4 down. Here's my starting point. And then since the value of a is negative 3, I go over 1 down 3. Negative 1/4 is even harder. I would probably go to 4. So my t-chart says 0, 0, go over 1 up 1 over 2 up 4 over 3 up 9 over 4 is 16. And then none of these are going to work real good for a fourth until I get down to the 16. The fourth of 16 is -4. So there's my movement from the start value. So let's find the vertex. The vertex is over 1 up 4. But then from this point, I'm going to use my movement over 4, down 4. 1, 2, 3, 4. 1, 2, 3, 4. So fractions make it fat. Over 1, 2, 3, 4. 1, 2, 3, 4. So those are the points that I would use. 3 points to determine a parabola. If you wanted to find additional points, you could. But I think that's enough. If you have any questions, please feel free to email me.